Hi, welcome back, class. All right, so now we will continue by 3.4.4, solving a system of linear equation by using a Gaussian elimination. Okay, Gaussian elimination, yes. So just now, what we have done is we solved the linear system of linear equations, okay, by using the inverse of A. But this inverse of A, we don't have to calculate it. We don't have to calculate, go through the long step. All right, we can get the inverse from the product of the matrices like this one. Okay, we get the inverse from the product of some matrices. Okay, now is if we are not given in this type of question. All right, so how we are going to solve it? Solve the system of linear equation. So we have another method, we call it Gaussian elimination. All right, so the Gaussian elimination, or we call it Gaussian elimination algorithm, okay, will involve reducing an augmented matrix. Still remember augmented matrix? Yes, we reduce an augmented matrix to a row echelon form. The row echelon form means the left hand side become an upper triangular matrix. Still remember upper triangular matrix? A matrix that you have diagonal, then all this becomes 0. Yes, to change it into this upper triangular matrix. All right, by using again elementary row operations. All right, so let's see how it happened. Okay, let's say you are given a system of linear equation. All right, so we are going to transform it, all right, into augmented matrix form. Okay, so before you transform it into augmented form, you can write it in the equation of matrix first. All right, write it in the form of equation methods, which the first one is all the coefficient of x, y, z. All right, all the coefficient of x, y, z, and the variable x, y, z, you write it here, and this is the solution. Okay, write in matrix equation form first. All right, then from here we transform it into augmented matrix form. So augmented matrix means we only write this one and this one. We ignore the variable first. So this matrix, write it at the left hand side, one straight line, then the S1, S2, S3. Yes, we express in this form. This is the augmented matrix form. If you want to use this Gaussian of elimination, write it in this way. So this is all the this is all the coefficient for x, coefficient for y, coefficient for z, and these are the solutions. All right. Okay. After we have done this, all right, so we are going to use the elementary row operation to reduce this augmented matrix to the matrix in row echelon form. Echelon form. Okay, which is become like this. All right, which is become like this. All right, the upper triangular matrix. So means all these three will become 0. Others, they change already. When we do the elementary row operation, all these other elements or other entries will change. All right. So why we want to express in this form? Okay, why we want to express in this form? Actually, we are going to see the most important is the third row number 3. This one. This one give us the type of solutions. So from row 3, you get fz equals I and solve for z. Then substitute the value of z into row 1 and row 2 to find x and y. Okay, so I will explain this one by using this one. By using this. See that? So remember, when you get this thing, when I write it back into matrix equation form, so it becomes like this, right? This is a matrix, this is the x, y, z, and this is g, h, I. I write it back. This is augmented matrix. I write it back into the equation form. All right. So remember, we are using first row multiplied column, second row multiplied column, third row multiplied column, right? We look at the third row. When third row multiplied with this one, 0, 0, fz. So will equals to I. Okay? So from here, we solve for Z lah. So Z is I over F. All these are numbers. All these are become numbers. Alright? And when we look at second row, so 0 dy plus Ez, then equals to H. Alright? Just now we already have Z ma. So sub in here, you can find your Y lah. Then we look at the first row. So first row is AX plus BY plus CZ equals to G. Just now you already calculate Z and Y. Sub in, then you will get your X lah. Alright? This is why we want to express in this row echelon form. Alright? So that from here you can get the solutions. Alright? And just now as I said, the third row is very important because this third row shows us the type of solution that we have. Okay, remember just now we have 3 types of solutions. Unit solution, consistent. No solution, inconsistent. And infinite many solution, also consistent. So from the third row, we will see the type of solutions. Okay, so the first thing that we are going to see is the value for F here. Alright, we separate into 2. Either F equals 0 or F not equals 0. Okay? So we will see F not equals 0 first lah. Okay? If F is not 0 here, is not 0, is some other values, then we say that matrix A is non-singular or invertible. Non-singular means it has inverse. It has inverse. And the system of equation is said to be has unique solution. Yes. So remember this. When F is not 0, then you have unique solution. You will have a set of value of x, y, z. Okay? If F is 0, alright, if F is 0, then we say matrix A is a singular matrix. Means no inverse. When F is 0, then no inverse. If F is not 0, then yes, it has inverse and unit solution. When F is not 0, then it's a singular matrix, means no inverse. Alright, then after we look at F, we also look at I. Yes, we split it into 2. Alright, so when F is 0, I also 0. Or if F is 0, I not 0. What happened? Okay, we see one by one. Okay, let's say if F equals 0 and I also 0. Means after you have expressed it into row echelon form, becomes 0, 0, 0, 0. So if this happens, we say that the system of equation is said to be consistent and have infinite many solutions. Yes, this is the example that it has infinite many solutions. Alright, so if infinite many solutions, how we are going to write the answer? Hence, we are going to write the solution in general way. In general way. So we will say let Z equals T. The last one first, Z equals T. Then from the second row, dy plus Ez equals H. Alright, then because Z is T ma, then you express Y in terms of T. Then like this. Okay, you express Y in terms of T. And to find X, you look at the first row. AX plus BY plus CZ equals G. Then your XY in terms of T already, you sub in, then you simplify it and get your X. Okay, so if it is infinite many solution, your answer of XYZ will be in terms of T. Alright, so you can refer to one example in your textbook. Alright, my textbook is page 181. You look at example 3.12. This is the example to show you that how they express the general solution in T. Okay, so please read it yourself. Okay, so just now is F0, I0, so infinite many solutions. Okay, how about if F0 and I not 0? F is 0, but this is not 0. Alright, so if this happen, we say that the system of equation is said to be inconsistent and has no solution. And has no solution. It's like the example that we have discussed here. Remember this that we discussed just now? When F is 0 and 9 is not 0 means we have something contra like this. So no solution. This is very important, this part. Okay, so this part is very important. So please memorize all these things. Alright, so after you have expressed your augmented matrices into row echelon form, okay, so we will look at the third row. First look at F. F0 or not 0. If not 0, unique solution. If 0, no solution or infinite many solution. Then it depends on your I. If F0, I0, infinite many solution, and your answer in general form is in terms of T. If F0, I not 0, then just no solution. Memorize this one. It came up quite often in STPM. Alright. Okay, number 6. Alternate method. For this method, we express the augmented matrices into the row echelon form. We stop here. When we stop here, we can calculate XYZ already. Alternate method, we call it Gaussian-Jordan elimination. Gaussian-Jordan elimination means we express the system of the linear equation in augmented matrix like just now. So use elementary row operation to reduce it into row echelon form. Alright, to determine whether the inverse exists or not. Alright, then the next step is we use elementary row operation to reduce the matrix again. Continue. We continue the elementary row operation and transform this matrix into canonical form. Still remember canonical form? Means just now it's like this, right? So we change all into identity. The left hand side matrix, we change it into identity using the elementary row operation. Then your XYZ will be these three answers. Okay? We will explain, I will explain both methods to you by using one example. Okay? Alright, so I will discuss a few questions. I will discuss 3 questions. Yes, I will discuss 3 questions. So 5, 7 and 9. 7 and 9. So all others will be your homework. Okay, this weekend you have a lot of homework. So please, okay, be more hardworking. Alright, and you will do question 10 as a quiz. Alright, so others will be your homework. Okay, so we will discuss 3 questions. Alright. Okay, so the first one, all this you can try at home. Try yourself. Okay, so we will see question 5. Can see? Alright, can see. Okay, good. Okay, so question 5, STPM 2013. Alright, so you are given a system of linear equation. Alright, where lambda and k are real numbers. Lambda is here, k is here. So you are asking to show that the augmented matrix for this system may be reduced into this form. This question they specifically want you to express in this form. So we have to follow. Okay. Alright, so first we express in augmented matrix form first. So all the coefficients for XYZ like this one, 1, 1, 1. 1, negative 1. 1, 1, 1. 1, negative 1. 4, 2, lambda. So 4, 2, lambda. Okay, XYZ no need. So K 0, 3. So K 0, 3. Alright, right in augmented method. Alright, okay, now the question wants us to do what? To express in this form. Alright, this one already 1. So no need to do anything. The second one is we have to change this one to 0. We have to change this one to 0. Okay, so I'm going to use row 2 minus row 1. then you get a new row 2. All right, new row 2. So row 1 and 3 remain the same. So I copy. 1 and 3 remain the same. I copy first. Then I do the new row 2. So R2 minus R1. 1 minus 1, 0 lo. Negative 1 minus 1, negative 2. 1 minus 1, 0. 0 minus k, negative k. Alright? The next step is this one 0 also. Alright? I want to change this one to 0 also. So I'm going to use R3 minus 4R1. This one minus this one times 4. Then I get new R3. I get new R3. So R1 and 2 remain the same. I copy. Negative. Okay, I copy first. Alright? Then R3 minus 4R1 here. So this one times 4. 4 lo? So 4 minus 4, 0. Alright? This one times 4 is 4. So 2 minus 4, negative 2. Alright? So this one times 4. So lambda minus 4. Okay? So this one also times 4. 4k. So 3 minus 4k. Alright? So the next one is 1, 0, 0, right? Hold on, let me see. Okay, this one I copy wrongly. Okay, I copy wrongly. Hold on. R2 minus R1. Correct lah. Negative 2. This one remain the same. Okay, correct. Okay, so 1, 0, 0, 1, negative 2, 0. 1, 0, 0. 1, 0, 0, 1, negative 2, 0. 1, negative 2, 0. So the next step is I want to change this one become 0. Alright, so to change this one become 0, I use R3 plus R2. Because I say they are the same. Okay, to get a new R3. So R1, R2 remain the same, I copy. Just copy. So R3 minus R3 plus R2, 0 plus 0. Negative 2 plus sorry, then it's minus. Minus, sorry, it's minus. Okay, minus. So 0 minus 0, 0. R3, R2, 0 minus 0, okay, 0. Negative 2 minus negative 2, 0. Alright, so this one minus 0, this one. And this one minus this one, yes. This one minus this one. So negative 4k minus k, minus negative k means plus k. So 3 minus 3k. So because the question wants us to show like this, so we have to follow. So we will check what we are going to change. Okay, so this one give you 5 marks. Not difficult, right? Not difficult because this is given, so we have to follow. Okay, done. Alright, then next, hence, determine the value of lambda and k so that the system of linear equation has, you see, these are the questions that they like to ask. Alright, each one 1 mark only, not many. Okay, so what are the values of lambda and k if the system has a unit solution? Alright, if the system has unit solution, remember unit solution? Just now here, is it? Unit solution. For it to have unit solution, f cannot be equal 0. This f cannot be equal 0. So come back to this one. So this is your f. So this one cannot be equals 0. So lambda cannot be equals 4. So means lambda can be any real number except 4. Alright? And how about k? So for unit solution, this one, for unit solution, we only see f. F cannot be 0 only. I can be anything. I can be anything. So means k can be any real number. I can be 0. So these are the lambda and k if the system has unit solution. Alright? And b, if the system has infinite many solution. Remember? For infinite many solution. Infinite many solution, f0, I also 0. So this is your f. F0, so lambda 4. And I also 0, so k equals 1. Alright, so for this system to have infinite many solution, your lambda will be equals 4, your k will be equals 1. Okay, next. What is the value of lambda and k so that the linear equation has no solution? So no solution is f equals 0, but this is not 0. Okay, can you remember? Unit solution, only look at f. F cannot be 0. Infinite many solution, look at both. Both also 0. If no solution, only this one. 0, this is not 0. So for no solution, f equals 0, so lambda equals 4. And this one cannot be equals 0. So means k cannot be equals 1. K can be any real number except 1. Okay, so they like to ask questions like this in STPM. So you must really memorize very well what is the condition for to have unit solution, infinite many solutions, and no solutions. Okay? Alright, so this one also homework. Question 6 also homework. There will be similar question. Okay, so the next question is 7. Alright? So this one came out in STPM 2015, Mathematics M. Can see? Okay. Alright, can see, Okay. Okay. So question 7. Using Gaussian elimination, solve the system of linear equation. So that just give you one system of linear equation. Alright, so again, first step, you are going to express this in odd method matrix form. Odd method. So all the coefficient for x, y, z, you see 1, 1, negative 1. First row. 2, negative 1, negative 2. Alright, 5, negative 1, 1. Alright, then this 0, 4, 2 here. Okay? So we know that we are going to express it as upper triangular matrix, right? Means this 3, we must change it to 0. This 3 change it to 0. Okay, so change this one first. So to change this one to 0, I multiply row 1 by 2. This one multiply 2 and minus 8 to get the new row 2. New row 2. So 1 and 3 remain the same. I copy first. Alright, so this one times 2. So 2. 2 minus 2, 0. This one times 2 is 2. 2 minus negative 1, 3. Times 2 is negative 2. Negative 2 minus negative 2, 0. Alright, this one times 2. 0. 0 minus 4, negative 4. Okay, so the next step is this one must be 0. Change this one becomes 0. So use the same operation actually. I multiply row 1 5 by 5, then minus row 3 to get the new row 3. Alright, so 1 and 2 remain the same. I copy first. Alright, so this one times 5. 5 5 minus 5, 0 This one times 5. 5 minus negative 1 means plus 1. Alright, so times 5, negative 5. Negative 5 minus 1, negative 6. Alright, so this one times 5 also 0 0 minus 2, negative 2. Okay, so the next one is to change this one to 0. Alright, so to change this one to 0, I use row 2. I multiply row 2 by 2, then minus R3 and get the new R3. Alright, so means R1, R2 remain the same. I copy first, then R3. So this one times 2, 0. 0 minus 0, 0. This one times 2, 6. 6 minus 6, 0. This one times 2, 0. 0 minus negative 6, 6. Alright, so this one times 2, so negative 8. Negative 8 minus negative 2 means plus 2, so negative 6. Alright, this is row echelon form. So I already expressed in row echelon form. Okay, then we are going to find my x, y, z. We always start with third row. Alright, third row. So remember, this one multiply x, so 0x, 0y, 6z equals negative 6. 6z equals negative 6. So I get my z equals 1. Alright, then look at second row. So 0x, 3y, 0z equals negative 4. So you get your y is negative 4 over 3. Then only go to the first row. So it's 1x plus 1y minus 1z equals 0. Alright, so y is this one, z is this one. So you get your x is equals 1/3. Alright, so question 7. They ask you to use Gaussian elimination, solve the equation of the linear equation. Solve the system of the linear equation. 8 marks. This is mathematics M lah, so you get 8 marks lah. Okay, so if come out in max T, maybe 6 marks only this question. Okay, so next I want to show you. Remember just now we talked about the Gaussian-Jordan elimination. This one, Gaussian-Jordan elimination. So what is this? So Gaussian-Jordan elimination is, okay, means that after we have changed it into row echelon form, or we don't stop here, we continue. We don't stop here and we continue, you see? I continue. From this step, I continue reduce it so that I get I. So let's say from this step, so 1, 2, 3, remember the next one is this one. I want to change it become 3. Become 1. So very simple. Just multiply 1/3. Row 2 multiply 1/3. Okay, 1 and 3 remain the same. So 0 multiply 1/3 is 1. So you get this. Alright, so 1, 2, 3, 4, 5 done. Remember, we go to this one. This one I want to change it to 1. So very simple. Just R3 multiplied with 1/6. R3, 1 and 2 remain the same. So R3 multiplied with 1/6. You get this. Alright, so 1, 2, 3, 4, 5, 6 done. Means next one I'm going to do this. Actually, you see second row and third row okay already. 0, 1, 0, 0, 0, 1. Only the first row. I need to change it to 0 and 0. So to change this one to 0, very simple. I use R1 minus R2 to get new R1. So R2, R3, just copy. Alright, R1 minus R2. So 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus 0, still negative 1. This one minus negative this one. Okay, and the last one is change this to 0 also. So to change this one to 0, I see that I can use R1 and R3. I use R1 plus R3 to get new R1. So 2 and 3 remain the same, I copy. So 1 plus 3, 1 plus 0, 1. 0, 0, 0. Negative 1 plus 1, 0. This one plus this one, 1/3. See, this is Gaussian-Jordan elimination. We don't stop here. We continue until we reduce the left-hand matrix become identity. Then this one will be your solution. So your x equals 1/3. Can see. Sorry. So just now, as I say, we reduce until we get identity. Alright? Then when you get the left-hand side become identity, the right-hand side will be your solution. So this is your x, this is your y, this is your z. Alright? Same as just now, right? You see? Just now also we get x equals 1/3, y equals -4/3, and z equals -1. Okay, so this is normal method. This is Gaussian-Jordan elimination method. So far in STPM, they never emphasize and ask the student to use Gaussian-Jordan elimination. So far we will use this one. Okay. All right. Okay. So next. All right. Next will be question 9. Okay. Question 9. STPM 2015. This is a long question. This is a 15 marks question. All right. You see, you are given the variable x, y, z satisfying the system of linear equation. So you are given a system of linear equation. K is a real constant. K is here. Okay, A, write a matrix equation for the system of linear equation. 1 mark. The question want you to write a, hold on, let me pull down a bit. Okay, so the question want you to, can see? Yes, can see it? All right, okay, can see. Okay, can see. All right, so A is write a matrix equation for the system of linear equation. They want matrix equation. This is matrix equation. Okay, 2, 1, 2, 4, 2, 1, 8, 4, 7. Then x, y, z. Then your solution 1k, k square. So this is the matrix equation. 1 mark. It's not augmented, so don't confuse this one and this one. This is matrix equation. This is augmented matrix. All right. So A, the question 1 matrix equation. So in this form. Okay. Then B, reduce the augmented matrix to row echelon form and show that the system of linear equation does not have a unit solution. All right. What is the meaning of does not have unit solution? Okay. So remember this, to have unit solution, f cannot 0. So if no unit solution means f 0. Yes, we must change until f 0. Okay, this is what you are going to do. All right, this is, I want to show you one example. All right, so I want to show you one example how we can do 2 operations in one step. I seldom do it, but if you think you can try, or else just step by step. Okay. So row echelon form means I'm going to change this one and this one to 0. Right? Row echelon form. Change these two to 0. Okay, so to change this one to 0, I use R2 minus 2R1. Means row 1 times 2. Then this one minus this one. Then you get a new R2. This one is to get a new R3. Alright, so means only R1 remain. So I copy R1 first. This one remain. Okay, so now change R2. So R2 minus 2R1. So 4 minus 4, 0. So R2 minus 2. So 2 minus 2, 0. So this one also minus 2. So this is times 2 is 4. So 1 minus 4, negative 3. Alright, so this one times 2. This one times 2. Alright, so k minus 2. Then third row. Third row, I want to change it to 0 also. So I use R3 minus 4R1. I use 3 and 1. So this one times 4. 4R1 times 4 is 8. So 8 minus 8, 0. Okay, this one times 4, 4. So 4 minus 4, 0. This one times 4 is 8. So 7 minus 8, negative 1. This one times 4. So k square minus 4. Alright? So this is what I mean before this. You can, in one row, you can do 2 operations. Okay, so the next operation is never mind. Okay, so the next operation is I'm going to change this one to 0, 0, 0. Actually, if you directly change this one to 0 also can, because no unit solution means this one equals 0, right? Okay, doesn't matter, same. Okay, so I use R2 minus 3R3 to get new R2. So R1 and 3 remain the same. I copy first. Okay, so R2 minus 3R3 here. R2 minus 3R3. So 0, 0, 0, 0. R2 minus 3. Times 3 is negative 3. So negative 3. Negative 3 minus negative 3. So 0. Okay. So this one also. Okay. This one times 3. Okay. So times 3 is 3k squared minus 12. Then this one minus this one. Okay, so 1, no k square ma, so 0, negative k squared. Okay, this one. Okay, 3r3 means 3k squared minus 12. Alright, then this one minus this one. Yes, this one minus this one. R2 minus 3r3. So there's no k square here, so 0. 0 minus 3k square. Okay, k minus 0, k. Negative 2 minus negative 10 plus 10. Okay? So remember the last step is actually we want to change this one to 0. Because no unit solution. Okay? No unit solution, F0. So I already have 0 here. So the next step is I just exchange row 2 and 3. This is also row operation, elementary row operation. Right? We seldom use this operation, right? We seldom use. Now you can use this. We just exchange these 2 rows. Then my F becomes 0 already. Alright? So we express into this form. Okay? Row echelon form. Then you see that third row, okay, suppose third row, all entries 0. So does not have unit solution. So complete part B. So the question, reduce until you make it no unit solution. So will be in this form. Alright? Okay, C. Determine all the values of k for which the system of linear equation has infinite many solutions. Then find the solution in case when k positive. 6 marks. Alright? So remember just how we say, no unit solution means F0. And when F0, it depends on k. It depends on I, right? If k 0, I also 0, infinite many solution. Alright, so the C they want infinite many solution. So to have infinite many solution, F already 0, this one also must be 0. Your I, okay, also must be 0. Okay, so we solve this quadratic equation and you get 2 answers. So when k equals negative 5 over 3 or when k equals 2, this system of linear equation will have infinite many solutions. Alright, then find the solution in the case when k is positive. So we have 2 values of k. This one negative, this one positive. So when k is positive, the question says when k is positive, so means k equals 2 lah. Alright, so what are the solutions? Okay, so I sub k equals 2 into the final row echelon form. Okay, so this one just copy. So this one, when k equals 2, so this is 0. When k equals 2, also 0 lor. Alright, so I express this row echelon form into this way. Okay, so look at row 2. 0x, 0y minus z. 0x, 0y minus z equals 0. So your z equals 0. Okay? Then 0, 1. Because row 3 all 0 cannot see anything already. So 0, 1, 2x plus y plus 2z, right? Equals 1. Alright, continue here. So because z is 0, alright? So left 2x plus y equals 1. Here is the place that we have to use the general solution. So let x equals t. Alright? Sub in here. When x equals t, alright? Then you rearrange it, you express y in terms of t. So y is equals 1 minus 2t. Therefore, this is the solution, general solution for this linear of system equation when k equals 2. X equals t, y equals 1 minus 2t, and z equals 0. Okay? So this part gives you 6 marks. Alright? Okay, can see it. Alright, so we have one more part, D. Okay, we have one more part, D. Find the set of values of k for which the system of linear equation is inconsistent. So you have to understand all these terms, you see. What is the meaning of inconsistent? All right, so remember this. When the system is inconsistent, it means that has no solution. And no solution means F0, I not 0. All right, F0 and I not 0. Okay, so go back to this solution that we have. I0, F0 already, no? F0 already, no? And this one cannot be equals to 0. Okay, this one cannot be equals to 0. Actually, we solve here already, you see. Just now we solve equals to 0, the same thing. Now solve not equals 0. So when equals 0, k is this one and this one. So when not equals 0, k is not this one and not this one. All right? And just now the question says the set of value of k, right? The set. So the final answer must be in set notation. So your k can be any real number except these two. All right? So this part only give you 2 marks. All right? Okay, so we have solved this part. All right? So I will stop for a while here for you to have time to complete question 10. All right? Complete now. Complete question 10 as a quiz, then upload your answer. All right? So after you have done, I will send the last video for the last part. Okay? See you later. Bye.